Sometimes steps in a process form a pattern. You can describe some of these patterns with a sequence or ordered list of numbers. Each number in the sequence is called a term. All right. Sequences it's just the pattern. All right. We'll get to series where you add them up. But sequence is just literally a pattern. You can have sequence of numbers. You can have sequences like this, where we start with a line and then we have this little guy, and then you'll notice that we do these little triangular shapes on each one and they keep building. That's a sequence. You can see the examples they gave us down here. Describe the pattern. 27, 34, 41, 48. What is the pattern there? What's happening? We're adding 7. Yeah. And so add 7, and then you can just keep going with that pattern as long as you want. Patterns can go up. Patterns can go down. Look at B. What's happening here? Yeah, we're dividing by 3. So we're going to look at specific types of patterns where it is specifically adding, it is specifically multiplying. But patterns in and of themselves, sequences rather, really can take any shape or form. They don't always do exactly the same thing. So sometimes you'll find where it's like adding odds. Add 1, add 3, add 5, add 7, add 9, right? So it just depends. It can be squares. It can be all sorts of things that can happen in a sequence. It's just that it keeps going. All right. And so you are looking for a pattern. You are looking to connect the pattern. We're just going to briefly talk about this. We're not going to actually do it. There is a pattern to the effect of gravity on something like a ball when you bounce it. In this case, it says it's dropped at a height of 10 feet. After it hits the floor, it rebounds to 85% of its previous height. That is a pattern. You are multiplying the height by 0.85 to see what the next height is. Same thing. It's a pattern. It's a pattern created by physics, but it is still a pattern. And so you see them everywhere. One of the things that we start doing is we start applying formulas to our patterns. We do that so we can then predict maybe a number way down in the pattern without having to write the pattern over and over. All right? And so we apply these terms. The little number to the right-hand side on the bottom is a sub number. So you'll hear the term a sub 1, a sub 2. That just means the first term, the second term, the third term. A sub n means whichever term I'm talking about. A sub naught will be a 0, meaning the first term, okay? And so you'll see those terms. In this case, they put a 1 there. Very often your first term will be a naught, a 0, all right? So just know that first term sometimes is represented with a 0. Types of formulas for these patterns. The first type of formula is called a recursive formula. A recursive formula defines a term by the term in front of it, just like you did on those two that I pulled up. I said, how is this being formulated? You said add 7. The only way you can get the next term is to have the previous one if you tell me add 7, right? Because if I say add 7 and I don't know where I started or where I am, I don't know what my next term is. That is recursive. When the formula is based on the number in front of it, it is a recursive formula. So you'll notice that it, like the little ball formula, 0.85, a sub n minus 1. That means whatever term you're on, you're going to look at the term in front of it, n minus 1. That's the term in front of it. So if I want term 5, I have to look back at term 4 and multiply by 0.85 if I'm bouncing my ball. That is a recursive formula. All right, so let's look at this guy. Describe the pattern that allows you to find the next term in the sequence. Write a recursive formula for the sequence. All right? So it says 2, 4, 6, 8, 10. What are we doing? We are adding what? We're adding 2. And so if I wanted a recursive formula, the recursive formula is always based on an unknown number. So we're going to use a sub n, meaning whatever term you want to find, I'm going to tell you how to find it based on the term in front of it. For this particular formula, the term in front of it is always going to be the n minus 1. And for this specific sequence, I add 2. So if I have any term in this sequence, I can find the next one by adding 2. That's what this recursive formula is telling me. All right? Find the 6th and 7th term. Well, I have 1, 2, 3, 4, 5, which means the next term is going to be what? 12. So a sub 6 is going to be 12. A sub 7 is going to be 14. What about 9? The 9th term. If I have the 7th term, how do I get to the 9th? Yeah, I have to add 4 to it, right? Because I added 2 twice. 11 and 15. What am I going to do there? I'm going to keep adding. So here's what happens. We're going to do this with the next one. This is great and all when we're on like 9. But what if they wanted like the 152nd term? We're going to be here a while, right? I'm going to be writing out even numbers until I get to it. And so what we're going to find when we have specific types, which we're about to talk about, arithmetic and geometric multiplication, is you can start creating a pattern that will give you any term, all right? So recursive formula is great when you're in your lower terms. Recursive formula is a pain when you want a really high numbered term, because then we're like having to add 2, and just walk our way to our answer. And so recursive formula works, and it is a formula you will use, but we're also going to introduce some other ones with our next two. So let's look at the next section.